Today I want to talk about Google Wave robots and in particular the new Robots API version 2 and some of the features that it has for robots to take advantage of. So to start with, robots are basically superhuman participants in a wave. They can sit on a wave and listen to everything that's happening in that wave, and they can respond by doing anything on that wave, like editing the text or adding replies, and they can even do stuff like creating new waves, just like a human can. However, robots are programmatic, and so as a developer, you need to understand how to actually program these robots in order to listen to the events that you want them to hear, in order to respond the way that you want them to respond. Alright, so to start off, let's actually look at an example robot. And we'll start by looking at what it looks like to the user of the robot. Alright, so in this example, we are writing a little diary entry about an incredibly emotional day with ups and downs, and we've got some little ASCII codes for smiley faces and frowns and all of that. So we write this up, and then we add the Skimmy robot onto the wave. So the Skimmy robot is basically an emoticon robot that goes through the wave and finds places that it can replace with emoticons. So after we add Skimmy, then we see that our smiley face has become a smiley face, our frowny face has become incredibly sad, and our heart is a beating red heart. So this is what it looks like to the user. Now I want to look and see what it looks like behind the scenes. So we go back to when we create this wave, and we add the robot. Then the wave server sees that a robot has been added onto the wave, and the wave server says, oh, well, I need to let this robot know that it's been added, and I need to give it some information about this event. So the wave server actually constructs a JSON, which describes the event and the context that it happened in. So in this case, the event is wavelet self-added, and the context is the wavelet that it happened in. So the context will describe the title and the text in that main blip and information like the participants, right? So it constructs this JSON, and then it sends the JSON to the robot. Now, every robot currently runs on App Engine, and every robot has a particular endpoint that the wave communicates with. So it's _wave/robot/JSON-RPC. So the wave server will send the JSON to that endpoint, and then the robot will process the JSON, and it will respond with its own JSON. And its own JSON will describe operations that it wants to perform on the wave. So for example, in this example, the operations are replacements, where it's going to replace the smiley faces with images and the frowns with images and all of that. So it sends a JSON of operations to the wave server, and the wave server sends those operations to the wave client, and now the wave client shows our lovely animated GIFs. So this is basically how a robot works. It's a application that accepts JSON RPCs and sends them back out itself in order to communicate with Wave. Now, you as a developer probably don't want to spend your time, deserializing JSON and serializing JSON, right? So what we do is that we provide APIs in the two main App Engine languages, Python and Java, and we let you use those APIs in order to process events and to respond to events. Alright, so here's the example code for the Skimmy robot that I showed, and this is in the Python API. So we start off by constructing the robot and passing in some profile information for the robot, and by registering a few event handlers. So here we're registering for the blip submitted and the wavelet self-added event handlers. Then we define a function that responds to those events, and that function receives the event information and the wavelet context, and it can use that information. So in this case, it iterates through the blip to see if there are any possible emoticons in it, and if it finds them, it constructs an operation to replace the text with an image. So it's basically just constructing a replace operation on the blip. And basically, this code is in fact deserializing JSON, turning it into Python objects, and then taking the Python operations and serializing those into JSON operations. It's just a much nicer way of creating this JSON RPC communication with the wave server. So that is basically a robot. It's a very typical robot, and we showed it in Python, but in Java it would be similar. And as you can see, robots are pretty much all about events and operations. So now I want to focus on various features of the events and operations aspects. So, starting with events. The whole point of events is to let developers subscribe to only the events that they care about and not have to worry about events that they don't care about, right? And this is because your robot is actually a web app, and you don't want your web app to be hit if it's not necessary, right? If there's nothing for it to process. You only want your web app to be contacted if there's actually something that your web app wants to process, right? So what we try and do is provide enough events so that you can subscribe to the ones you care about and ignore the ones you don't care about. So here's a list of the events that we have currently. There's stuff like title changed, participants changed, blip created, form button clicked, gadget changed, etc. There's our most high frequency event called document changed, which is something like, every 4 characters that they type, you'll get an event. And so these really range in their frequency. But these are the events we offer now, and we may offer more events in the future as developers express that there's something else, some level of granularity that they need. But you can do an awful lot with the current events here. All right, now we said earlier that when a robot sends event or receives event information, it also receives context information, and the context describes the wavelet that event occurred in. Now, in the API, we have this notion of you being able to specify your own context and for there being a default context. So the reason for this is because some waves can be really, really big, and there are some developers that want to know about that entire wave and all that information, and there are other developers that really only care about one blip in that wave. So we want to make sure that if you're a developer that cares about the entire wavelet, you can get all of that. But if you're a developer that only cares about a little bit, then you're not going to worry that your robot is going to get hit up with this, massive amount of information every time there's an event. So we have a default context, and then we let you override that default context depending on your particular needs. So for example, looking at this wave here, there's a blip in the middle that we're editing. That's the one selected in green. And then there's several blips around there, and then there's a parent blip. So the default context is root, self, parent, and children. So in this case, it would be the selected blip, it would be the root blip, the one with the title, and there would be a parent, the one right above it, and there would be no children. So the default context here would give you a JSON describing 3 blips of information. Now, you can override that context to specify any one of these context options or any combination of them, right? So if you're a robot that only cares about the current blip, you might override it to say you only want self. If you're one that cares about the entire blip, like you're a robot that exports a blip to PDF, then you would specify all, so you get all of that information. And the way to do that is simply when you're registering the event handler, you just specify the context as one of these constant or a combination of the constants. And then the wave server will know to only send the specified amount of context to your robots. Okay, so we also have a notion of event filters. Now, there are a lot of robots that like to actually respond to particular things inside a wave, right? And process those things that it finds. They're basically looking for matches and processing those matches. So ideally, those robots would respond in real time, meaning those robots would be listening to the document changed event. And as soon as they saw something that they matched, they would go ahead and process that match. Now, if the robots are listening to the document changed, then they're potentially getting a whole lot of events. And it's possible that they're going to get a lot of events that have nothing for them to process, right? So what we let you do is actually set a filter on the event to say that you only care about the event if the event text actually matches a certain regular expression. So looking at this example here, this is intended for a robot that converts bracketed text into Wikipedia links, right? So the robot wants to respond immediately on document changed and convert those immediately, but it only wants to be notified of those document changed events if there's actually bracketed text for it to respond to. So all we have to do here is when we're registering the event handler, we will also specify a filter, and the filter is just a standard regex that says what the text should match for your robot to actually care about it. And then your robot will only get that event when the filter matches. And then presto, it can do all of its replacements in real time. So the event filter is a nice way of having a robot that responds in real time, but isn't constantly notified of events that it doesn't care about. Right now, you can mostly use the event filter on the document changed event, and a few other events like gadget changed and annotation changed. And we'll probably continue to add the filter to other events as it becomes desired. Okay, so now we have operations. And this is basically the robot doing stuff. So the goal of operations is to let your robot do as much as a human can, right? So basically do everything inside of Wave. So here's a list of current operations that we support. There's stuff like replying, adding and removing tags, adding participants, inserting inline blips, appending HTML. These are all really useful for modifying an existing wave. We also have an operation called create wavelet, which will create a new wave, and fetch wave, which will fetch a wave that the robot is on. Those are two new operations that we added in the recent API. Now, when you're doing the document modify operations, there's a lot of elements that you can insert into a wave, and here's a list of the elements. There's a lot of form elements you can insert. You can also insert lines, which lets you do bullets and headings, and also insert gadgets, installers, and images. And there's a lot you can do with gadget-robot interaction, so that's pretty crucial to look into. Okay, now, this is probably the most exciting part of our new API, and that's what we call the active API. So in the past, in the old API, robots could only do operations in response to events. And this is kind of the way I've also presented robots so far. But in fact, in the new API, robots can do operations at any time. So this means that you can do stuff like have your robot create waves from another web page, and do stuff like have your robots perform operations from a cron job, which really opens up a whole new range of robots that can be created, and also makes it much easier to integrate with third-party systems, because you can have your robots respond to events on the third-party system, or have your robot respond to actually web forms on that third-party app. So the way we do this is we just have you register your robot, and we basically give it a OAuth consumer key and consumer secret, and you put that key and secret into your code. And once you've done that, that means that you're now able to do operations at any time. And we will authenticate you every time you do those operations to make sure that you're all validated. So this means doing stuff like creating a new wave from a form. It means stuff like fetching a wave at any time and doing operations to it. There's a lot of possibilities once you start making active robots. And this is one of the really exciting things in the new API. And along with that, we've introduced the notion of proxying for. So this is another thing that's really crucial for integration with third-party systems. because the thing is that third-party systems usually have their own notion of users, and you often want to represent contributions from users on third-party systems inside of Wave, right? And represent it visually so that it makes sense. For example, we might have a Twitter robot. The Twitter robot updates a Wave with replies that represent tweets from Twitter users, right? So here's tweets from Dawa's Twitter account, right? And as you can see, the avatar and the name, that's all actually the avatar that Dawa uses on Twitter. This is all pulled from the Twitter system. And this is nice because somebody who's used to seeing their tweets on Twitter and now sees them in Wave, sees them looking very much the same. So they think, oh yes, this is the same user. I know who this user is. Even though Dawa on Twitter isn't really a Wave user, he's a Twitter user. And what's actually happening is that these operations are all done by the robot. They're just done by the robot on behalf of a user. And this is just done using a plus syntax in the robot address that represents that user. And then there's a profile that's pulled for whatever's after the plus. So it's good because it means that you can make waves look like they're contributed from those other users, but you can always prove that they came from the robot. So that's good for having some credibility. Now the way to do this in the code is for every operation you can simply prepend the proxy for method, and that tells the API that you want to do an operation on behalf of a user. So here we're going to do a reply on behalf of Dawa. Now in order to let them know what profile information to serve for operations from that user, you just create a profile handler, and that profile handler gets passed a username, and for each username you respond with their profile information, their name, their image, their profile URL. So it's really fairly simple, but with that combination of stuff you can really represent users from third-party systems much better. Alright, so that is basically the new Wave Robots API version 2, and hopefully you check it out and make your own robot and let us know how it goes in the forum.